Good morning, students. I am Professor Palash Jain, Assistant Professor Electrical Department, Sagar Institute of Research and Technology. Today we will teach you the cylindrical coordinate system in subject electromagnetic field theory. As you all are aware that in the previous session we have seen the basic parameters of cylindrical coordinate system, that is the rho, phi, z. We have studied how to make the cylinder on the coordinate axis, and we have also learned the basic range of all the three parameters, that is rho, phi and z. Now if we revise all the three parameters, we will see that rho is the distance measured from z axis, phi is the angle measured from x axis and xy plane, yeah, or I can say that azimuthal angle, and z is the distance. And I have teach you the basic method, that is a very simple method, that is how to draw the cylinder. First we have learned that cylinder is made up of three parts: uppermost circle, lateral surface, that is the curved surface, and the third one is the bottom circle. So to make all the three surfaces we need three parameters, that is rho, phi, z. And we have also seen one assumption, that we have taken always the surface is at infinite, and according to this concept we have find out the range of parameters, that is rho, phi, z. Now in today's class we will discuss the differential length, differential surface and differential volume for the cylindrical coordinate system. Now to understand or to learn, or I can say that to find out the differential length, differential surface and differential volume for cylindrical coordinate system, I have written over there the three formulas for Cartesian coordinate system of dl, ds and dv. I have written over there because so that we can compare easily, and from the older formulas we can easily derive our current formulas for cylindrical coordinate system. Now if we start with the Cartesian coordinate system, you see that we have simply the dl is equal to dxax, dyay and dzaz. Now if we find out the differential length for cylindrical coordinate system, we know that for cylindrical coordinate system the basic parameters are rho, phi and z, and for Cartesian coordinate system the basic parameters are x, y and z. Now many students think that, sir, please replace these x, y, z parameters, differential parameters and these unit vectors with rho, phi and z. Yes, I can easily replace, but there will be a slight change. Now I tell you that. Now for cylindrical coordinate system, you can see that the dl is same as dl. For dx I have written here d rho. For ax I have written here a rho. For dy you all will see that I have written something different over there. We will talk about this later. Now for ay I have written a phi. For dz I have written dz, and for az I have written az. Now here you will find out two things. Many students ask, sir, the third parameter is exactly similar as that of the Cartesian coordinate system, but how? So you all have understand one thing, what? Ki in cylindrical coordinate system the third parameter we have talked about is rho, phi and z. This is our third parameter, which is exactly similar to x, y, z. In Cartesian coordinate system the third parameter is z. In cylindrical coordinate system the third parameter is z. So our third part is already same. Now here I have for in place of dy I have written over there rho d phi. Why I have written over there rho d phi? So I will explain over there. For example, if you talk about the cylinder, you have seen over there three surfaces. The first is your upper circle, the second one is your lower circle, and third one is your this curved portion, that is the lateral portion. So to find out the differential length across this lateral surface, we need the measurement of this curved surface. Okay, so we need the measurement of this curved surface. I can also say curved is arc. The arc and curved are both the same things. And in your mathematics, in basic geometry section in schools, you have learned that theta is equal to arc upon radius. So this is our arc. So what will be arc? Arc will be equal to theta into radius. Okay, and what is theta? In cylindrical coordinate system there is only one angle, so theta will be equal to your d phi. I have written over there. And what is radius? Rho, so it will be equal to rho d phi. That is why I have written over there rho d phi a phi. Unit vector will be same, that is a phi, but for dy I have written over there rho d phi. So x is replaced by radius, z is same, and for y I have not written here d phi, I have written rho d phi. Okay, now the second most important thing I am now telling you is, for Cartesian coordinate system our parameters are like this: x, y, z, and in differential format it will be written as dx, dy, dz. Okay, you all understand over there. Now in cylindrical coordinate system our parameters are rho phi z, but in differential format our parameters will be d rho, rho d phi and dz. So from the above formula we can easily conclude that for Cartesian coordinate system our parameters are x, y, z. Okay, so what will be their differential parameters? See in the differential length formula dx, dy and dz I have written over there. Now what are the parameters of cylindrical coordinate system? I have written over there rho phi z. Now what will be the differential parameters for cylindrical coordinate system? We will see the differential length formula. So what is written over there? D rho, rho d phi and dz. So in the second parameter second term you have to consider that lateral arc, or I can say that the lateral curve. Now if we talk about the differential surface, in differential surface in the Cartesian coordinate system, what we do, we simply multiply the two differential parameters. Okay, now if you multiply dy and dz, okay, the unit vector will be opposite, that is ax. If we multiply dx and dz, unit vector will be opposite, that is the remaining one, ay. If we multiply dx and dy, the unit vector will be the remaining one, that is the z, az unit vector. Okay, now we will talk about here. Now you see here the differential surface formula for the cylindrical coordinate system. What we have done, we have multiplied all these three parameters. So in the first step I have multiplied what? I have multiplied d rho and rho d phi. D rho and rho d phi. So what will we become? Rho d phi. Now which is the remaining parameter? Z. So I have written the unit vector of the remaining parameter z. Now we have multiplied rho d phi and dz. So you see rho d phi dz, remaining parameter a rho. Okay, now we are multiplying the first and the third, that is d rho and dz. I have written, and the remaining parameter is a phi. So I have written over there the unit vector of the remaining parameter. So in this way we have easily learned that how we will find out the differential surface for cylindrical coordinate system. Now if we talk about the differential volume part, so in Cartesian coordinate system what we have done, we have multiplied all the three differential parameters dx, dy, dz. Similarly in cylindrical coordinate system we have multiplied all the three differential parameters. And what are three differential parameters? That is 0, rho d phi and dz. So you can easily see that these are the differential parameters for differential volume for cylindrical coordinate system. Now many students have confusion. They come and say that, sir, why have you multiplied these differential parameters? If we are finding about the length, surface and volume, we will simply multiply the parameters. Okay, so they asked that, sir, differential surface we will multiply, sir, x, y and az. No, this is not the correct way. I have written over there dx, dy, az. This is the correct thing. Why? Because we are talking about the differential surface, differential volume and differential length. The word differential here comes, and differential always means dx, or I can say that d rho. And in the previous sessions I have already told you that the differential part is very small part, very differential part, very small part. I have already told you that. So students, today we have learned the three basic things, the three basic parameters: differential length, differential surface and differential volume. In the next session we will learn about the transformation of cylindrical to Cartesian or Cartesian to cylindrical coordinate system, and in the next session we will see the numericals based on these topics. Thank you all for today.